So let's study about processes in Linux and Unix. What we are, what are the various processes of Unix and Linux we have? See, a process is a concept by which we can understand and control the execution of a program in an operating system. We have working, we are working in different kind of operating systems, and as per the current syllabus, we are right now discussing about Linux and Unix. So here the process is defined as a running instance of a program. Each process is in Linux system is identified by a unique process identification number named as PID. Each and every instance of a program, when it is initiated, it is executed, it will be having its own PID number, right? And these are allocated by the kernel. Each process contains information that are needed by the CPU to run the program. Each and every information is circulated by the CPU. After all, the CPU is responsible for conducting for the running of all instances, or we can say for the running of all processes. Whenever in a Linux system any application run, any application moves, it is actually a process. A program or a command creates only one process, but an application, on other hand, has the capability to start multiple processes to accomplish various tasks. Whenever we are actually trying to do a particular task, in Linux system, it's not only single process that initiated. At that time, number of processes are actually taking place. Now, according to the definition of Linux process system, we are dividing a process into different address space. Whenever processes take place, at that time, each and every process takes different address space or they need a different segments. These segments are of three types. We having a text segment, we having a data segment, and we have a user segment. The text segment contains the code that needs to be executed. Since several users may be using this area segment, so this area remains fixed. Every time when a particular process is going to be executed, it needs some space where it has to be executed. It got some preparation for the before execution. Now, the second segment that is being used by every process is a data segment. Data segment, all the data that program uses like array and variable are held here. Then the user segment. The segment contains all the attributes related to the process, namely user IDs, group IDs, more, and this information is used by the kernel to manage all processes. Each and every process and group of processes are having their own user IDs and group IDs. Then we are having different other kinds of processes in Linux process management. Like we having a parent process, we having a zombie process, we having a child process, orphan process, and daemon process.
So we have to discuss about the make utility of a Linux, or we are talking about the make files in Linux, which is uh, which is a very simple and organizes code compilation very simple, and very easily we can able to use it using a simple command make make, right? So it's having the ability to compile any number of programs all together using a single command. And this is to automate the compilation of multi-module C projects, and it also reducing the error. For that, we need first of all to keep all the C source files in a single folder. That is the section underscore C here we have taken, and we have considered here a very small project of addition of two numbers and subtraction of two numbers. And for that, we are use first of all, we are like to explain about add.c file. That is one of the source file we have with us. Here we are just taking two variables a and b, and we are adding them, and we're returning its value. And in the on the top, we are just declaring its header file, that is add.h, right? So this is one of the way, and rest of all the programs are going to be saved in the same folder, that is section_c. In the same way, we have a add.h, which simply tells that these are the that add function is going to be used in this project, and it is having two variables. Right? So in the same thing, we are having the main.c program with us, which is containing one header file, standard input output file, because we are using printf and scanf, and it is also we have to include both the header files, that is add.h and subtract.h, and then we are just initializing two variables here, x and y, as 10 and 5, and then we are adding the two numbers using the add function and subtracting two numbers using the function subtract, right? So in this way, we are simply calling the two functions add.c and subtract.c in the main source file that is going to be used here. Then the main thing comes in the make file, where each and every line is having some its importance. For example, in the very first, we are talking about the compiler. We are just telling that this is the GCC compiler we are using, and we are having the compiler flags which are enabling all the warnings. Then after that, we are talking about the target program. We are talking about the object files, that main.o, add.c, and subtract.o. All the object file com- will be compiled as a single variable, that is obj. Then after that, we're having a default rule, which is actually all colon target. So whenever we will use the command make, it will automatically build the program, program, and it will give all the compiled files, and it will joins all the object files after linking step, and it will create a final executable file, which is a program. So for the compilation rule, each C program, each C file becomes object file, whether it may be a main.c, or it may be add.c, or it may be a subtract.c. So all will be becoming object files. So and also one important rule, that is a clean rule, which is simply very important for us to write, and it simply deletes all the object files and executable programs that going to be happening. So whenever we are working in this very way, we have to recompile only that file which we have made some changes. For example, here, if I have just made the changes on add.c, I have to recompile only add file, not the subtract file, right? So this is a very beautiful advantage we have with us, that whatever changes are being done, we have to compile only that. Now for the main part, whenever we have to execute the files via terminal, we have to first of all we have to ensure that make file should have all these things or all the syntax ready, and then we have to come to the terminal part. At the terminal part, we have to first of all ensure that we have to be in that particular folder where all the source files are stored, right? So we are at section_c where all the files are stored. So after reaching at section_c, we have to simply write make command, which simply execute all the modules that we have with us using the GCC compiler, which is installed in our machine, and we are able to execute all the files, all the source files, and after that we got a program in a program we have a final executable files with us, so that could be easily we'll got the result by dot slash program, and we can able to see the result, and that is addition 15 and subtraction 5, right? So the final executable file is created after running, and we are able to see the results, right? So this is the way how we are able to execute our multiple program. It could be any number, and very easily we can use these things to make our compilation and software making. So to understand the grep command, that how using this beautiful utility we can easily able to identify and match the particular pattern from a text file. The very first we need to create a file, any text file we can create. Let's create it using a cat command. Using cat command on a terminal, I am creating any text file, and then in that particular text file I am writing some text. Maybe I am writing the names. So I have created a file 3 underscore year, that is a third year, and then I have written few names like Himanshi, Himanshu, Himanshi, in which I have written the triple I at the last, and then Rinko, Rinki, right? All these are the names that I have written. And now let me write a command, grep command, and let me extract some content from these names to implement the star and dot operator, that is asterisk and dot operator from the file, right? So let me write a grep, and then I have written a rinky, which is present here with the different spelling, and then have to give the name of the file grep ranking 3 underscore year. So I don't have a rinky exactly RINKI, but I have a RNIK double I. So it will identify the same like that, right? And the same thing if I have trying to uh, match the Himanshi, which is then it will give me the output of Himanshi with the single I and with the triple I also. So it is simply extracting the data which I am giving you in any number. Right? But let me write a star, or you can say asterisk after Himanshi. So it after writing a star, it will give me the text of any count, maybe zero or more occurrence of a particular character, that is I, whether the I is available or any not available or any number of available, it will give me the all the Himansh word. It may be Himanshi, it may be Himanshu, it may be Himanshi with the triple I, right? So that is a asterisk operation with the grep command, or the option available in grep. So in the same way, grep with the rinky, if I'm writing, so whether I occurrence of I is 0, or maybe the occurrence of I is more than 1, it will give me that text. So it is giving me rinku and the rinky with the one more I. And the same way, if I'm using the dot operator, which is any single character except a new line or replaces the one character. So wherever Rinky is repeating with a single character, that will display, but no any other things will be displaying, right? So I'm having Himanshu in the same way. If I am having any single character of Himanshi is present, it will be showing me the last value only, right? So in this way, we can discuss the utility of these. So if I'm having a double I dot, so it is again showing me the complete word. But if I'm writing Himanshi dot, it is just giving me in that way. So if I'm just writing Himansh dot, so it will be giving me all those values that I'm having, right? So in this way, we can conclude that all both of these operations are very good to understand and to use while grep command.